Exactly. It's just like, how can you make a plant menacing? Good luck.
Could do anything in the movies.
Yeah, right, sure. Like maybe from, what's that?
Anything can
Rocky
happen
Horror.
in the
No.
movies.
The Little Creature, Little House of, Little Shop of Horrors. Yes. Yes. But no, they didn't make them like monster plants. They just made them regular old plants. But they'd show them in a menacing way.
I gotta see that movie. What's it called again?
The Happening.
The name in and of itself
Is it on
sounds not
Netflix?
good.
It was, I want to say, but probably not now.
Netflix has all those B horror movies. I love it.
I don't even think it's a B, honestly.
Yeah, it's like a Z.
I really hate that movie.
Why did they stop calling things F's? Like, why is it a Z now? Like,
I don't know.
You know?
Make them worse.
I don't know. Like, isn't F not a thing in Great Britain?
No, Z's like so teachers use Z's in different ways. So like I use Z for like something like someone missed that day, so like a Z is the same as a 0 basically. So but I use a Z for like a student missed the day, they can still make it up. But if you like if you earn a 0 for something like you just didn't do it kind of thing, then I put a 0 in. But I guess teachers use them in different ways. Okay. When I student taught in Prince George's County, they had A, B, C, D, E. They didn't use F's. I always wondered why we skipped E's to just F's. But anyway. All right, so talking about the Richter scale for these logarithmic word problems. Okay, the Richter scale measures the magnitude, capital R, of an earthquake of intensity, capital I, using this formula. Okay, so capital R equals log of capital I over capital I sub 0. Okay. Where I sub 0 equal to 1 is the minimum intensity used for comparison. Okay, so we're going to find the intensity, and you will not need to have this like formula memorized or anything like that for the test. You'll be given whatever kind of formula you need. Again, you just need to know how to use it. Find the intensity I for each earthquake given below. Okay. By the way, just as a heads up, intensity, how do you measure that, right? It's a measure of the wave energy. Of an earthquake. Okay, so they're able to measure the wave energy of the earthquake itself. Okay, and we'll look at 2. Okay, we'll look at 2 here. So in number 1, in Nevada in 2008, okay, there was one that was a 6.0 on the Richter scale.
Wow.
6.0 in 2008. Okay. And we're going to then find I, the intensity here. Okay, so 6.0 is the R value, so we'll put that in for R. And we'll say that's log of I over 1. We're just going to compare it to a minimum intensity earthquake. Excuse me. Okay, so how do we solve this here? What should we do to solve for I? Use 10? Yeah, remember log, right? The common log, just use 10 to the left-hand side and 10 to the right-hand side. So we have 10 to the 6th equals, well, essentially I over 1 and just I there. So in other words, I is going to be 1 million. Now, I'm not sure what the units are for this. I'm not sure on the units. Okay. Let's see here. Give you guys one try here. All right. In eastern Sichuan, China. There was one that measured a 7.9. That was also in 2008. Oops, I'm off the screen. Excuse me. So go ahead, try that one. I know, I feel like if you were a seismologist, I think they're the ones that study earthquakes. In 2008, you're like, giddy up. Tons of fun earthquakes to study. And then you forget, like, oh yes, there are people's lives get destroyed by that. So maybe you're not as excited at that point. Trying to see if I can get the units, figure out the units here. That's true. That is an important thing.
He didn't wake me up today because of that. So.
He didn't warn you either, though?
No, he did.
Oh, okay.
He did, but I just couldn't get up.
Huh. Yeah, okay. I still don't have... I'll try and get some units for this, but anyway. So Eastern Sichuan, 7.9. Okay, we'll still do the I over 1 there. And we'll raise it to 10, or 10 to the power of each side. And so you should get an intensity of 79,432,823.47. Yep, talking about earthquakes here. So,
oh, like on the Richter scale?
exactly right. Yep. So the important thing to remember here on the Richter scale is that when you raise the scale, when you raise the point, I guess, or whatever, when you raise the scale, the score, I guess you say on the Richter scale, when you raise the score by a single point, that means the earthquake has 10 times more, or 10 times greater intensity. Okay, so you know, going from an earthquake that was a 5 on the Richter scale to an earthquake that's a 6 on the Richter scale, that 6 is 10 times more intense, right? It's not like a just like, oh, one more point. It's 10 times more intense kind of thing. Okay, so at each point you kind of go up on the Richter scale, it's 10 to that power more intense. Okay, so just keep that in mind too. All right. So yeah. All right. So that's anyway earthquakes application with the logarithm. another common application with the logarithm has to do with decibels. Okay, we're actually going to go to the book here. So let me pull this out.
Every 10 points, it multiplies by 10, doesn't it?
Every 1 point increase multiplies the intensity by 10.
Really?
You're talking about for earthquakes now or decibels?
decibels.
Oh, decibels. I think yes. Every 10 points it multiplies.
Yeah, every 10 points it multiplies by
Multiplies
10.
by 10. I think so. Yes. We'll see here. I've got it right here on page 266. This is like an example out of the book, like I said. Okay. So, here we are. All right. Use the following information for determining sound intensity. Okay. The level of sound there, beta, in decibels with an intensity of I is given by beta equals 10 times log of I over I sub 0, where I sub 0 is an intensity of 10 to the negative 12 watt per square meter, which is corresponding roughly to the faintest sound that can be heard by the human ear. So again, what we're doing here is taking something, like the quietest thing you can possibly hear, or earlier, right, with the earthquake, it was like kind of like the lowest intensity earthquake that can register, we call it just a 1 kind of thing. And so here, for our purposes, the lowest intensity sound we can kind of detect is 10 to the negative 12 watts per square meter as that kind of intensity. So we're going to then compare them to other than intensity levels to measure then their decibel, give them a decibel quantity, right, to compare them and stuff like that. Okay, so we'll take a look here. So you'll see some interesting ones here, right? We have like different scenarios. We have like a quiet room, a busy street corner, a quiet radio, the threshold of pain. That's neat. All right. So rustle of leaves, jet at 30 meters. Okay, you can see also that's 10 to the 2, that's 10 to the 0 for threshold of pain. So if you're 30 meters away from a jet, there's a good chance you're going to be in some pain there. Door slamming, siren at 30 meters. Okay, so interesting stuff here. All right, so let's see what kind of decibels we're dealing with. So let's see. I think I chose to do 65A and 65B, but we'll do threshold of pain. That might be a fun one too. All right, so anyway, again, the decibel level, beta, is equal to 10 log of I over I sub 0. And again, for this case, I sub 0 is 10 to the negative 12 watts per square meter. Oh, sorry, I didn't realize. There we go. Okay. So let's do a quiet room. Quiet place. See, I should have realized The Happening is too old for you guys. Like, it's too old. It's too old. So. Okay. All right. Let's see here. And again, for A, this is the quiet room, which is 10 to the negative 10 watts per meter squared, and that's the quiet room. Okay. Oh, I'm off the screen again. There we go. Okay. So we'll just plug in our values here and see what the decibel level is. So 10 times log of I, so I would be the actual intensity of this thing we're trying to measure here, so that would be the 10 to the negative 10th, over, and we're going to compare that to the kind of like our base level, which is 10 to the negative 12th, the lowest sound that is detectable by a human ear. Okay. And so to solve this, we're just going to kind of plug and chug, right? There's not a whole lot of solving to be done. We just type it in. So 10 log 10 to the negative 10th divided by 10 to the negative 12th. Okay, and we get 20 decibels. Let me make sure I spell that correctly there. Okay, so quiet room, 20 decibels. Okay. Let's try another one here. Let's just jump to the threshold of pain. Letter D. See how many decibels it takes to hurt your ears, to cause you physical pain. And I just really messed it up. Okay, that was the letter D on 65 there. All right, so for threshold of pain, it's 10 to the 0 watts per square meters. So 10 to the 0 over 10 to the negative 12th there. Pain. All right, so let's see here. Well, again, we can do this mentally, really, but okay, it's going to be 120, but type it in your calculators if you like. Yep. 120. Yeah, this is actually pretty easy to do without a calculator too, if you think about it, right? I mean, to divide two numbers with the same base, you subtract your exponent. So 0 minus negative 12 gives you positive 12. So this is 10 to the 12th. Log of 10 to the 12 is 12, right? Because it's log base 10. So log of 10 to the 12th is 12 times 10 will give you 120 decibels. Okay. 120 decibels, and then you can start feeling pain. Yes?
My alarm clock rings at 120 decibels.
It does?
Yes.
Does it hurt your ears?
Might set it full volume, yeah, a little bit.
Yeah? Mm-hmm. I believe it. Okay. Actually, I feel like also, you know, just, well, yeah. Now that's, of course, the threshold of pain, but that doesn't mean that you can't be hurting your ears at the lower levels, too. Let's see here. How many decibels? How many decibels
It still doesn't do the job to get me up, though.
cause hearing loss? 85 decibels can cause hearing loss. And even sounds of less than 75 decibels after long exposure, sounds of less than 75 after long exposure are unlikely to cause hearing loss. But long or repeated exposure to sounds at or above 85 decibels can cause hearing loss. Okay, so be careful. But I know you guys like to listen to your music and your headphones real loud, but
I'm not sure if my alarm clock's set all the way up right now.
oh, I got you.
Maybe
Well,
I should check.
yeah.
It should definitely be set all the way up if I'm going to be getting myself up.
Yeah. So, that's a good question. All right, so that's pretty much it. All right, just those two. I just wanted to give you like a little taste there of some logarithm word problems, and that's all I got. All right, that's it. It was pretty quick. Okay. So, what I've got for you guys then for the rest of class, you have a couple options. All right, I have posted to Google Classroom our I have posted our assignment.